Hey there, welcome. So what I want to talk about today in this video is special right triangles. And this video is more designed for someone who's already learned about special right triangles. So if you're looking for like a ground up foundation where you don't know anything about special right triangles, this video is not for you. But for if anyone else has maybe learned about special right triangles but is struggling to remember how the sides go together or how to use them, I just want to give you a couple of tips and tricks that have worked for me and might help you to be successful. Okay, so just a refresher of things that you already know. Special right triangles include 30, 60, 90 triangles and also 45, 45, 90 triangles. And then they have these very cool ratios that remain constant, which are essentially this idea that we have on a 30, 60, 90 triangle, the shortest side is represented by the number 1n, and then the longest side is twice that length, right? So like 2n, and then the medium side here is kind of n times square root 3. And then for 45, 45, 90s, it's the 1, 1, root 2. So I've actually denoted these ratios with the ratio portion here in orange. And here's why. It's because anytime you want to basically find some scale factor of these sides, it's going to be n times any one of those ratios. So I genuinely don't even care about n. It's not really that important to me as long as I can keep track of that 1, 2, 3 ratio on each side. So how do I keep track of those 1, 2, 3 ratios? All right, so here's a couple of silly things that I do to help me keep track. I just remember that 30, 60, 90 triangles are as easy as 1, 2, 3. And here's a way you can remember that. I don't know if this is mathematically valid, but it's kind of cool that if you take the degrees 30, 60, and 90 and divide each one of these by 30, well, you actually find that you get the numbers 1, 2, and 3 back. So you can almost think about 1, 2, 3 as being those ratios on your degrees as well. Okay, so now that I've got the 1, 2, 3 figured out, I don't know how you're going to remember this, but I always just remember that 3 has a square root around it. Again, not quite sure why that makes sense to me. So that might be the only thing you actually have to remember without having a good trick for it, like dividing by 30 and getting the 1, 2, 3's back. Okay, so now, how do I know which way to put them around the triangle? I'm going to erase what I have here so that I can clearly explain how to place them on the triangle without them already being present. Okay, when placing each one of these ratios onto your triangle, all you have to consider is the size of the numbers and the size of the angles. So for instance, the smallest angle on this triangle is the one at top, which of course has to be my 30-degree angle. It's the smallest angle. And there's a correlation, which is actually due to Hinge theorem, which says that the size of the angle is proportionate to the size of the opposite side, which kind of makes sense if you consider opening a door. Let's say I have a closed door, and then the farther that I open that door, well, the opposite side gets larger and larger and larger. And so there's this correlation that if I have a small angle, then the opposite side is small. But if I have a large angle, then the opposite side over there is large. So that's what Hinge theorem basically says. And that's going to help me to place these numbers correctly onto my triangle, because I know that the smallest angle must be across from the smallest side. So which one of these numbers is the smallest? 1. So that means that 1 goes here. Okay, next one I want to figure out. What's my largest side? Well, the largest side is always going to be across from the largest angle. There's that correlation again. My largest angle is the 90-degree angle, and so that means my hypotenuse, of course, is the largest side. Now, which one of these numbers is larger? You can very simply plug square root of 3 into your calculator and find that it's like 1.89 something rather. But I also like to just use the fact that, well, 2 is actually the square root of 4. And the square root of 4 must be bigger than the square root of 3. So technically 2 is the largest number in this set. So that means that 2 goes on the largest side of my triangle, the hypotenuse, leaving my medium-sized number here to fit across from the medium-sized angle, which is 60, and so this is square root 3. Okay, The cool thing is that all the stuff I've shown you for 30, 60, 90s, dividing the angles and everything, is kind of going to be the same over here for 45, 45, 90s. Check it out. If I divide everything by 45, or each one of these angles by 45, then I get 1, 1, square root 2. And then if I want to place them onto my triangle, well, it's pretty clear to me that square root of 2 is larger than 1 and 1. And so this must go with my hypotenuse. Again, I don't really have a great way of remembering that this has to be the square root of 2, but I do just remember 1, 1, 2, and then the 2 takes the square root. So if I want to place them onto my triangle correctly, I know this thing about 45, 45, 90s is that when these base angles are the same, these 45s, that actually means that the opposite sides are equal to each other, which is a result of hinge theorem again. Okay, so that must mean that these two equal sides go here and here, and then the square root of 2, my largest side, has to go across from my largest angle, right there. And then, like I said at the very beginning of this video, if you need to multiply by some kind of scale factor like n, then it's just going to be these same ratios, 1, 1, root 2, but you'd multiply by some kind of scale factor of n. And so it might look like 3, 3, and 3 root 2, or 6, 6, and 6 root 2. Or same over here, if you have to multiply by some scale factor of n, the ratios will remain the same. And so it might be something like 2, 4, and 2 root 3, or 5, 10, and 5 root 3. So hopefully using these tricks, where you're dividing by those angle measures and you get 1, 2, 3, is a nice way of remembering, or you also have the 1, 1, 2. Again, find some kind of way that makes sense to you to remember which number takes the square root. And maybe that will just come over time of using special right triangles more and more throughout your life. You'll just begin to remember those things, much like how I did. Okay, I hope this video was helpful. Have a great rest of your day.